120 centimeters. The higher the goal is that you could get balls up to, the more points you score. At the Cedar Bluff competition in early January, just before the third match of the day, Will, Thomas, and I were waiting for the match to begin, and I noticed the way the sentry roll was positioned. It was set in one of 3 randomly chosen positions. And I asked Will, in autonomous mode, the robot is supposed to drive straight forward, right? He said, yeah. I said, what if we positioned the robot in such a way that it ran straight into the kickstand? Knocking down the kickstand would gain our team many points. Will thought it was a great idea, which then allowed us to start matches, either on the ramp, which Will had created an autonomous program for, or on the playfield in the parking zone, which we did not, at the time, have an autonomous program for. When the autonomous period started, our robot propelled itself forward, knocking down the kickstand, releasing the balls from the center element. This change in strategy allowed us to score lots of points. I was excited that our strategy idea worked out. Due to the designs that I created in both PTC and SolidWorks, we were awarded the PTC Design Award at the Boone, North Carolina qualifier in late January. We were very excited to have received this award, as it showed that all the hours of hard work we had put into learning the program and designing the parts had paid off. We were honored that PTC funded our team this year, and our thanks goes out to them for their support. And now to Will, who will speak about programming and the engineering notebook and outreach.
Hello, my name is William Wakely. I'm 14. I've been interested in a career in engineering for most of my life. FTC is a great way to learn those engineering skills and is a great way to learn those science, technology, engineering, and math skills needed for a career in engineering. I've been inspired by CERN, the Apollo moon missions, and the NASA Curiosity Mars rover, because if we can build a giant subterranean machine for smashing subatomic particles, put a Volkswagen-sized scientific mobile instrument on the red planet, and put people in space, what is the limit to what we can do? I'm also really grateful to the library for all the years that I've spent reading books checked out from here and being inspired by what I find within. I'm really grateful that they let us present today, and I'm grateful that they have let us give back in a meaningful way through this presentation. I'm hoping to go on to Caltech or similar for my undergraduate degree, then on to Carnegie Mellon for my graduate degree, hopefully going on to NASA to work on the team that is going to land a probe on Europa, one of Jupiter's moons. One moment that really embodies all the experiences that we've had so far is the night before our second competition, one that Luke was talking about. We were testing a linear slide, which you can see an example of over here, and it had some of our 3D printed parts on it. And we were winding the motor up to raise the lifter when about halfway up it fell. Okay, a big deal. It's heavy. So we increased the motor power, but it still didn't go up. And then I noticed that one of the wires was coming in at slightly too low of an angle, and I shut off the lifter. After examining it, we discovered that one of the wires had actually bitten about halfway through the parts. Oh, okay. One of the wires had bitten about 1/4 of an inch through one of the 3D printed parts. We were all really dispirited by this, because if this continued, we weren't going on to the competition tomorrow. I was searching around for an old prototype in a back corner of the room that we were in. It hadn't worked well. It was semi-malfunctioning, but it worked. And I found an aluminum baking pan that you might make buns or lasagna in. And I thought, wait a second, if the wire's cutting through the part because the part is too soft, what if we coated the part with something harder, like aluminum? So I got a pair of tin snips and started cutting through this pan and got a strip of it, one for each, and got several strips of the aluminum, one for each of the parts. And then we cut slits with a Dremel through the parts, excuse me, and wrapped the aluminum foil around the parts. And it worked. In fact, it worked better than before because the aluminum was smooth. It allowed the wire to slide over the parts. And that one moment, that one eureka moment, where you think, that's it, that's how we're going to solve this thing. That's why I'm in FTC. It's that moment where you figure out how something's going to work. And I've had many of those moments with our programming language, LabVIEW. LabVIEW is a graphical data flow programming language. This means that instead of the typical line-by-line approach, you have blocks and wires. The blocks represent blocks of code, and the wires represent variables traveling between those blocks. Data flow means that each block only executes as all the inputs needed for that block get to it. This means that instead of worrying about where the code is going to run, you can worry about how it's going to run. Because if block A needs to run before block B, you just make it so that all the inputs for block A get to block A before all the inputs for block B get to block B. Does anyone here use LabVIEW? It is an extremely flexible programming language, capable of anything from simple instrument monitoring to rocket launch control. It's used by such corporations as Eastman, SpaceX, ExxonMobil, and many other large corporations and universities. Oop. Last year, I had almost no knowledge of advanced LabVIEW programming, and I was only able to make the robot have simple functions during driver controlled, and it didn't even move during autonomous. This year, I was able to incorporate knowledge that I had learned from Schrödinger's hat, another FTC team that I will talk more about later, and the FTC Tech Network, which I will also talk more about later, to program more complex and intelligent structures of code, allowing for dynamic and adaptable operation. For instance, I was able to use a color sensor for the NXT brick, the microcontroller that we have to use in FTC, to make the robot sense the color of the ramp underneath it and thus drive forward. I was also able to, as Luke described, make the robot knock down the kickstand. I was able to program more efficiently and with much less design errors than last year. I'm looking forward to learning more about LabVIEW and incorporating such features as rising and falling edge triggers in driver control to sense when a motor has reached the end of its path or if a servo has gone too far. I'm also looking forward to using case structures to program complicated structures of code in autonomous mode. Now you've got to document all this, and that's where the engineering notebook comes in. The engineering notebook is one of the most crucial, if not the most crucial parts, if not the most crucial part of all of FTC. It's a record of the team's journey, the team's thoughts, the team's experiences. It's a record of the team's thoughts, the team's journey, the team's experiences, the team's knowledge. This doesn't mean that it's a perfect finished document, however. The FTC expects that you will have errors, you will have mistakes, you will have stains, but that's okay, because not only does that show growth and learning, it shows that, hey, we made a mistake, okay? Let's go on and learn from that. It shows character. FTC expects that the notebook will contain all of your sketches, all of your drawings, all of your designs, and hopefully printouts of your CAD models. You also hopefully will have printed out a screenshot of your LabVIEW code and pasted it into the notebook. It's exceedingly important. It's used for 14 out of the 15 awards available in FTC. And we know this because this year we were recognized for 3 awards, all of which depend upon the notebook. Now, you can, and this has happened many times, show up with what amounts to a heap of parts for a robot and a stellar engineering notebook, and you can go on to the next level of competition based solely on that notebook. Now you've got to document outreach as well, like what we're doing now. Outreach is the process of talking to people about FTC and STEM, science, technology, engineering, and math. This can range from workforce outreach, which is talking to professionals in the workforce about, about learning STEM and helping the team, to talking to kids and adults about FTC, how to get involved, learning STEM, and you can also, there's also other outreach with other teams, which is discussing design, strategy, things like that. Last year we led educational workshops at the Bristol Public Library here and the Johnson City Public Library, where we showed 60 to 100 4 through 12-year-olds the basics of circuitry design, such as making a battery out of conductive Play-Doh and having them make simple LED lights that they could take home. We participated in the Bridgeforth Design Studio Who Art Thou Camp, showing our robot and telling about the design process and presenting about the design process. We also had presentation tables at North Carolina Maker Faire and Kingsport Mini Maker Faire, showing our previous year's robot and demonstrating FTC and STEM knowledge. Last fall, as Thomas mentioned, we started an FLL team for younger kids interested in robotics. We have been so lucky to have community support partners. We have met with Kenny Cornett and Keith Nekoff at RCAM, Regional Center for Advanced Manufacturing, where we printed some of our prototypes and some of our finalized parts, such as the collar and the items. We've also met with the professors at UVA-Wise, where we printed our finalized parts, the red and black parts, at their Maker Mondays, which are open to the public on the first Monday of every month. We made our lifter drums at the 1940s machine shop of Power Pneumatics in Bristol, Tennessee. That's the lathe that you can see there. We have made connections with Daniel Sandoval, a professional electromechanical engineer in Johnson City, Tennessee, who graciously mentored our team through our season. We've also contacted 2 engineers and robotics specialists, at NASA JPL, where we had a mentoring discussion talking about real-world usage of science, technology, engineering, and math knowledge. We are still looking for mentors, so if you or someone you know is interested, please contact him at the end of the presentation, the guy who just raised his hand. We have also been in contact with several other FTC teams across the globe. We are part of the FTC Tech Network, which is a global network of FTC teams dedicated to sharing knowledge between FTC teams. We are regularly in contact with FTC Team 3595, Schrodinger's hat, not cat, in Fairbanks, Alaska, who were amazingly kind. This year they partially mentored us through our season in LabVIEW and solid modeling. We have also been in contact with the Enterprisers in Reno, Nevada, who helped us with 3D modeling and 3D printing. We are going to be attending the Richmond workshops later this year for the 3rd year in a row to continue honing our FTC skills. We also have several currently planned events. I am going to be presenting at the upcoming Cedar Bluff workshops, where I will be teaching LabVIEW and SolidWorks, a programming language, and CAD modeling. We also have several events that the public can enjoy. Next month, we are going to be doing the Global Near Space Balloon Launch Challenge, which is open to the public. You can either start a team, or you can come watch our team launch our balloon, which details will be posted on our website. We are also going to be on July 18th presenting at the Kingsport Mini Maker Fair for the 2nd year in a row. We will be presenting our robot again. And August 1st and 2nd we will be presenting at RobCon right here in Bristol. And talk to us afterwards for more details about these events. And here's Camille, our media specialist.
Good afternoon. My name is Camille Gray, and I am a homeschool junior. My role on the team is outreach and communications, and my responsibilities include managing our website, our social media pages, and helping plan our outreach events. I work at Twin Roses Designs. I volunteer at Theatre Bristol, where I'm also the Youth Service Board President, and I have danced for over 14 years. My brother Luke is a founding member, and though I am relatively officially a new member, I've been around since the beginning. I hope to get a greater understanding out of the team about not just how to use technology, but how it is built and how it works, and the study and creation of moving objects as applicable to dance, theater, and humans. First, I would like to talk a little bit about gracious professionalism. Gracious professionalism is a staple in FIRST competition. It is the brainchild of Dr. Woody Flowers, and he is a FIRST National Advisor and Professor Emeritus of Mechanical Engineering at Massachusetts Institute of Technology. Gracious professionalism is competition, kindness, participation, working together, effective communication, and preparing for a workforce that calls for it. Our team applies it by working politely and happily with other teams, when seeking help, gladly accepting criticism and input, when offering help, providing useful and thoughtful information, and when communicating within our own team, from building a robot to programming it, to simply socializing and having fun together. Gracious professionalism is beneficial in life because employers want to hire happy, gracious professionals in communication with future partners and potential children, and generally speaking, with love and respect to everyone. Regarding gracious professionalism, I would like to quote from FTC's website. Quote, "In the long run, gracious professionalism is part of pursuing a meaningful life. One can add to society and enjoy the satisfaction of knowing one has acted with integrity and sensitivity." End quote. Next, I would like to talk a little bit about the scholarship opportunities through FIRST. FIRST offers almost 200 scholarship opportunities in every state, plus Canada, Mexico, Australia, Israel, and Turkey. These are mainly for engineering, but there are currently 65 available for any field of study. These vary from one-time $500 awards to a full 4-year tuition. There is over $20 million available in scholarship opportunities for FIRST students. And last, I would like to talk a little bit about the diversity of FIRST. FIRST greatly encourages diversity among their students, crossing age, race, and gender boundaries. However, across the FIRST organization, only 35% of students are racially diverse, and only 23 FTC students are female. Consequently, First has a majority of white males. And even though they are on teams in general, First found that their female students are more likely to lead their teams in terms of fundraising, marketing, service projects, and presentations, whereas the males are more likely to be directly involved with the design, build, and programming of the robot. Nevertheless, females are excelling in First. Young women who participate in First are 4 times more likely to study science and engineering in college than young women who don't. Across the board, because of FTC, 78% of students feel that they do better in school because of First, and students' interest in pursuing math and science has risen by 84%. Personally, First benefits me because I plan to pursue an artistic career in a very technical world, and having knowledge of both of those things is very important. And though, currently, I am a statistic in terms of team roles, I intend to break that, learning everything I can, from sketching out the robot and its parts to programming and driving that. I'd like to close with First's mission as stated by its founder, Dean Kamen. Quote, to transform our culture by creating a world where science and technology are celebrated and where young people dream of becoming science and technology leaders. End quote. Thank you.
As you've all seen, the amazing experiences that these children have been able to go through over the past 2 years that we've now operated our program. As I'd mentioned before, we realize that there's an incredible need for programs like this in this area. Southwest Virginia and certainly Tennessee are simply not served to the level that they should be by First.